A uniform string has a mass of 0.3 kilogram and a length of 6 meters. While I'm reading, I'm going to try to understand what's given to me. So this 0.3 kilogram is the mass of the string, and 6 meters is the length of the string. So it passes over a pulley and supports 2 kilogram objects. I'm going to call it mass of the object. Find the speed, so this is the v that is asking, of a pulse traveling along the string. Okay, so let's pull our information out in a more organized form. So I'm going to write mass of the string equals 0.3 kilograms. Length of the string equals 6 meters, and the mass of the object equals 2.00 kilograms. We want to find out the velocity of the pulse, the speed of the pulse, and that's it. Okay, so this is the picture that I drew for the situation where we have a string that supports the object. Here is the mass of the object, and then we have the entire length to be 6 meters. Okay, well, from this point, I am thinking, what do I know about the speed of pulse? We have derived and discovered that the speed of a pulse or a wave equals square root of the force of tension over the linear mass density. Now, I neither have a force of tension nor the mass density. So both of them are something that maybe I can see if I can find. So let's see, what do we know about linear mass density? Well, for linear mass density, I am going to write the definition. That is the mass. When we talk about linear mass density, obviously we're talking about the string. So that's the mass of the string over the length of the string. So I can plug in the numbers and find what it is equal to. So mass of the string, we know it's 0.3 kilograms divided by length of the string is 6.00 meters. And so if we plug it into our calculator, we will get this equals 0.05 kilograms per meter. Now, the next question is, how do we find the tension? Well, from mechanics, we know that if we want to find a force, free body diagrams are kind of necessary. So let's see for the object, what is our free body diagram? So if this is my object right here, there are two things that are acting on, two forces that act on this object. The first one is the weight of the object, okay, which is downwards like that. That's the m naught g. And then we have the tension of the cord or the string. So free body diagram will look like something like this: m o g, m object of g, which is the weight, and then force of tension. Since it is just supported, it's not moving, so acceleration should equal to 0. Now I'm going to write the equilibrium condition where force of tension minus m object times g should equal to 0. From here I can find force of tension equals mass of the objects times g. And next thing, we want to plug in the numbers. That is a 2.00 kilograms times 9.8 meters per second squared, and that equals 19.6 newtons. Okay, so now that we have the linear mass density and we have the force of tension, we can actually plug that into the equation about our speed of pulse, which equals, okay, so I'm gonna just use the colors that to plug in 19.6 newtons for the force of tension, divided by let's see what we got for the mu, and that is 0.05 kilograms per meter. So I'm gonna write 0.05 kilograms per meter. Okay, so the next thing we want to do, we want to plug it in into our calculator, and then this will give us a value that equals 19.8 meters per second. So this would be our answer. Thanks for watching.